Wow. Hello, everyone. Congratulations to you all. You are highly welcome back to my YouTube channel, the channel where we give outstanding information because the channel is outstanding and information is basically about chemistry. All right, it's no longer news that alternative A chemistry is coming up this week, specifically on Thursday. It's coming up on Thursday, specifically on Thursday. That's the 16th of this month. All right, I will be doing a final preparation for the practical. Final preparation for the practical is very, very necessary because I want to see you coming out in flying colors. Got your bag. I want to see you having outstanding results. Okay, starting with the alternative A, 16th of this month. Okay, now we have three questions. Question 1, question 2, and question 3. Okay, question 1 comprises of titration. Question 2 comprises of salt analysis, while question 3 is a general question. So let's quickly start with WAEC Practical Chemistry 2024. Let's start with the Redox titration. Okay, I have some questions that were prepared that we can use to learn, even though we are not conducting it live on this channel. All right, now the question of titration here says A is a solution of 0.01 mole per dm of KMnO4, and B is a solution of FeSO4. Okay, put it into the burette, prepare 25 cm3 portion of B. Of course, that will be put into the conical flask. We are going to add 20 cm3 of dilute H2SO4, so acidify FeSO4. Then you titrate the resulting solution with A inside your burette. So repeat the titration to obtain constant titer values. Then tabulate your burette readings and calculate the average volume of acid that is used. Now, looking at what we have here, we have equation of the reaction. The reaction is between an oxidizing agent and a reducing agent. And you can see the oxidizing agent here is MnO4. Okay, while the reducing agent is Fe2. Okay, now let's quickly look at it. Now, from the result, calculate the amount of moles of water of iron 2 in 25 cm3 of solution B, concentration of solution B in mole per dm3. Why are we not using indicator in these particular reactions, and what type of reaction is this? So let's see how example of how our table should look like. Let's see example of how our table should look like. Now quickly, let's look at the table below. The table below, this is a calculated value. Anyway, it's a calculated value. So this is how the table should look like. A standard table should look like. You have your burette reading, you have your final reading up, you have initial reading, then you have your volume of your acid. Now, your initial reading starts from 0.00 all through, and these are the final reading that was obtained. Now, for this particular experiment, I'm going to be making use of the first titer and my third titer. Okay, 18.1, 18.1, then divide by 2, making my final answer is what? 18.1. If WAEC will mark this one for you, Mike will mark this one, and Mike will mark this one. Of course, they will give you 4 marks each, making 8 marks. Mike will mark this one, give you 1 mark, and this one also 1 mark. So we are expecting 10 marks on this table. If and only if we did not cancel anything, we didn't cancel anything. Okay, you follow the rules of the table, you get 10/10. Okay, on this particular table, which is a free mark for anybody. So if you are sitting for this WAEC on Thursday on 16, make sure you not cancel anything on the table. Make sure your decimal are 2, and make sure the differences between the value you are using is not more than 0.15. WAEC make use of 0.15. But you are very smart. Your own can be 0.1 or 0.00 differences. Look at my differences. The difference between 18.1 and 18.1 is 0.00. So that's a smart move. That's a smart move. Okay, very smart move. Okay, let's move to the questions quickly. And the first question says we should calculate the amount in moles of iron 2. Now, the formula that is used in calculating amount in mole is amount in mole is equal to concentration in mole per dmq times volume over 1000. Okay, the conc in mole of B given is 0.01. Okay, you can see it here. When you multiply by this, you have 0.002 moles. That's of what? Of B. Good. Now, the second one says you calculate the concentration of B in mole per dmq. We can use Kava. Okay, Kava here is saying the concentration of A. Our A is the oxidizing agent, which is the KMnO4. Our B is the Fe. So our A here is this. Now, let's really look at it. We are looking for concentration of B in mole per dmq. Now, this is our formula here. Now, WAEC will give you 1 mark for this mole ratio. So make sure you follow this rule. Okay, WAEC will give you 1 mark for 1/5. Now, how do you get 1/5? 1/5 is arrived from our balanced chemical equation. 1 is from here. You can see it, 1 mole from here, and 5 moles from Fe 2+. So let's go back to our calculations. So we can substitute the values of Ca, which is 0.01, our calculated value for Va, which is 18.10, and so we are looking for Cb. This 25 is a standard pipette. Okay, in your school, if you are using 25, you write 25. In your school, if you are using 20, then you can put 20. Okay, all right. Now our mole ratio. WAEC will also give you another 1 mark here for correct substitution. I hope you are following now. Now, when you go down to change of subject or formula, if you can change it correctly, WAEC will also give you another 1 mark, making 3 marks. And your final answer must be to 3 significant figures. Please, I beg you, let your final answer be to 3 significant so that you can be able to get that particular mark. Now, the next one is, why is indicator not used? The KMnO4 is a self-indicator because of the color that it have. And what type of reaction do we have in this particular reaction? The type of reaction here is called redox type of reaction. Okay, that's our question 1. Let's quickly proceed to question 2. Now, question 2, I will not be using any table again. Okay, I'll make use of my calculated value for the VA that I have above. Okay, I'll make use of my calculated value that I have above. Okay, let's quickly look at question number 2. I say 0.01 mole of KMnO4 again, and this time around I have my B to be 2.75 gram of FeSO4 in 500 cm3. Okay, in 500 cm3. All right. Now, from this, using the same procedure, titration, blah blah blah, you get your calculated value. Let's use that one as our case study. So we have to calculate from our result to calculate concentration of FeSO4 in what? In B, in gram per dmq, and the concentration of FeSO4 in mole per dmq, and the mole ratio of your oxidizing agent to your reducing agent, which is A and B. I love this practical. I love this question. All right, you can see in this question there is no equation given, so there is no way to get mole ratio. There's no how to get the mole ratio you are expecting. So please, if the kind of question come, you have to be smart. You don't need to write it. Now let's look at how to calculate the first one. Okay, first one is calculate the concentration of what? Amount in mole. So let's really calculate that. Now, before you calculate the amount in mole, you have to change the concentration of B from 500 cm3 to standard one, which is 1000. So we change it from here. then we have this. Okay, this is now in gram per DMQ. This one in gram per DMQ, I must convert it to what? To mole per DMQ. In converting to mole per DMQ, I'm going to find my molar mass. Okay, the molar mass of FeSO4 is 56 plus 32 plus 16 times 4, everything give us 152. Please, 152 gram per mole. Anytime you are calculating molar mass, make sure the unit is gram per mole, or else it will not score. Okay, I'm a WAEC examiner, I mark WAEC, so I need to give you these tips. Stay close. All right, we got our 5.5 gram. Then we use this formula to calculate our mole per DMQ of B. Now, if you have done that, remember your mole per DMQ must be in what? Must be in 3 significant figures. Look at it. 3 significant. Can you see it? So let's calculate the amount in mole. Amount in mole, the formula is this. Of B mole per DMQ times volume. Remember, our volume is 25. Okay, this is a case study of 25. In the whole school, if you are using 20, you use 20 to calculate. So this is my mole per DMQ times my volume divided by 1000. I have these moles of B. That's the moles of B that I have. So let me proceed to the next one. Now, amount in moles of Mn, which is my oxidizing agent, in the titration now. Okay, that's the volume of my acid. Okay, that's the calculated value from question number 1. So I have this value multiplied by this and give me this, which is my mole of what? Of A. Now, how do I calculate mole ratio? Remember, I have the mole of acid. The mole of A, sorry, there's no acid there. The mole of A, which is the oxidizing agent. So I'll put it there. Ratio mole of B. No, the next thing I'm going to divide by the smallest. Divide both sides by the smallest. The smallest here is 0.00181. So when I divide it by smallest, I have my 1:5. Okay, if you look at the first question we solved, you discover that the ratio of the A to B, oxidizing to what? To reducing agent, is 1:5. Okay, but remember, if this kind of question comes out, you don't need to write equation. You don't need to write equation. Let's do one more questions before we go into salt analysis. It's a revision time. It's a revision questions, so that all what you have been preparing for, you use this one to revise. Thank you for staying tuned up to this level. I trust you that trust God in you that you will write well that day and you will pass. Another question, which is last questions for this Redox Titration on this channel. Now, it contains 1.5 gram per DMQ of KMnO4, while B contains 10 grams of FeSO4.XH2O. Okay, now looking at this in BMQ, and the molar mass of this guy is 158. And the only equation is what we have here. At least by now, everybody should know that having equation is very important. Okay. Now, from the result and the calculated and the experiment that you have done in the lab, what do you need to do? What is the concentration of A in mole per DMQ? Concentration of B in mole per DMQ. Molar mass of FeSO4.XH2 in B, and the value of X. So how do I calculate this? How do I calculate? Let's look at the formula to use. Now, we are supposed to calculate concentration in what? In A. Okay. A. Now, what's my A? My A is KMnO4. I have 1.5. 1.58 divided by 158. So it's giving me 0.01. Okay, but I make it to 3 significant figure again. So I want to score. I want to get my mark. Okay, must be 3 significant. Look at this, 0.0100 mole per DMQ. Okay, I'm done with my conc mole per DMQ. Is that cheap? Is that cheap? The next one is to calculate my mole per DMQ for B. So I'm going to use conc of A, which is my oxidizing, as against conc of B, that's CAVA like that. So I follow the same rules. Look at my mole ratio, that attract 1 mark. Then I'll substitute my value here for mole for a conc of A. Then my calculated value for acid. Then my pipette value, which is 25. Then my mole ratio. This is another 1 mark, making it 2 mark. If you can substitute very well, okay, WAEC will also give you another 1 mark, and your last answer is also another 1 mark. Okay, making 4 mark. Remember, look at my last answer is always to what? 3 significant figure, 3 SF, 3 SF. Okay, I have 3 SF there. Okay, now quickly let's look at the next one. Now I need to calculate the mass, the molar mass of FeSO4. Which formula am I going to use? Okay, I'm going to use a formula that says concentration of B in mole per day equal to conc of B in gram per day over molar mass. Remember, we are given 10 grams. Let's go back to the questions. We are given 10 grams. Look at my 10 grams here of FeSO4. Okay, and it's already in DMQ. So I'm okay with that. So I have this, and I just finished calculating this, which is this. I'll just have my subject of formula, so 10 divided by that, I have my molar mass. Remember, I told you earlier, your molar mass must be in what? Must be in gram per mole, because that's the standard unit for what? For molar mass. So I have my molar mass already. So the next question says calculate the value of S. Okay, the value of S, this hydrated value is going to equal to my molar mass. Then I'll substitute the respective values of Fe, S, oxygen is 16 times 4, then plus this dot here means what? Plus. Then the value of hydrogen is 1, the value of oxygen, and there are 2 hydrogen making 2, then the value of oxygen is 16. Everything equals to this. So 56 plus this plus 32 plus 64, that's 16 times 4, 64. All right, 1 times 2 plus 16 making what? 18. So all this, okay, give me what? 152. All right, now with 152, from there I will quickly rearrange my values. Okay, make X now is sort of a formula, then this comes to this side, then I have this, I have 124.2. Divide both sides by 18, then you have your value to be what? To be 6.9. Okay, when you approximate that value, you have 7, you have 7, you have 7, you have 7. So our formula now becomes FeSO4.7H2, which is iron 2 total of a 6 heptahydrate. Before you go to our next one, because the next one we are going to now is to quickly revise the salt analysis. But if you have not subscribed, make sure you do so. Make sure you subscribe. Make sure you click the notification button. Make sure you share this video. Make sure you watch it to the end. Thank you for watching to this particular end. So let's quickly go to salt analysis. Now the salt analysis, what we are actually expecting on Thursday, okay, is a mixture of 2 soluble salts. A mixture of 2 soluble salts. Now, Na2CO3 is soluble. PbCO3 is also soluble. But they have asked us to mix these 2 salts together. And you know, as a chemist, if you are mixing 2 salts together, something will come to mind. What will come to mind? It will come to your mind that definitely they will ask you to filter a particular salt. But we have 2 soluble salts. So there will be double decomposition for these 2 salts, and they will precipitation will take place to form PbNO3, which is insoluble, and NaNO3, which is soluble. Now look at the possible ions you might have. You might have these ions, and you can have this gas. You can have these ions, and you can have this gas. But when they react together, okay, and we are to filter. If you are going to filter, that means we will have this one that is insoluble as a residue inside the what? Inside the filter paper. We have that one as a residue inside the filter paper, and the possible ions are this Pb2 plus, CO3 2 minus, and the possible gas is CO2 gas. Positive gas is CO2 gas. All right. The one we are going to have the filtrate is going to be NaNO3. NaNO3. And the possible ions Na plus, NO2 minus, and NO2 gas. So let's quickly go to the salt analysis. See, prediction is what and what can come out. So let's just see what and what can come out. But believe me, it will definitely come out. So let's start with this. Look at how we represent this in chemistry. Okay. We have three columns. We have test, we have observation, and we have what? Inference. So if you are asked, the salt is going to be mixed together in 1:1. So as a student, you don't know, you just give you a salt. But as a tutor, the instruction has been given for you to mix the salt together for the student. So plus water, C will partially soluble or dissolve in water. If you have to filter, it's going to give us, you can see partially soluble. If you have to filter, to give you a colorless filtrate and a white residue. Okay, we cannot say that this mixture is a mixture of soluble and insoluble salts, because we all know that the two salts are soluble. So the best statement to use here, the best word to use is mixture partially soluble in water. Mixture is partially soluble in water. Okay, now this one, if you ask to test with litmus paper, okay, we realize that there is no effect on litmus paper, and solution C is neutral to litmus. Let me remind you, please don't say C is neutral to litmus if they ask you. Tell us that solution C, because you have already dissolved this. Okay, it has been dissolved. It has been dissolved. Since it has been dissolved, of course, is now a solution. Okay, it's no more C. Okay, let's look at some likely approach. Okay, some likely approach that might work. If the WAEC comes in this way, okay, you have filter, you have residue. What is, take a portion of the residue, or of the filtrate rather, and add freshly prepared FeSO4. There's a reason why they ask freshly prepared. If your Fe is not freshly prepared, there will be oxidation. Ion 2 will be oxidized to what? To ion 3. When you do that and you add your conc H2SO4, please, tutors, please make sure you help the students to add H2SO4. Don't leave them to add H2SO4, because students are students, okay? They will only play with it. And when they play with it, it's hazardous, it's dangerous to their body and to their health. Please help them to add it in case the question, in case the WAEC asks the question. So our observation will be a brown ring is formed at the junction of the two layers. Very interesting practical when you test this. And we have NO2 present. The brown ring is due to the formation of what we have there, FeSO4 N2. FeSO4 N2. And let's quickly look at this. Another portion of the filtrate plus conc, ordinary conc H2SO4. We have a reddish brown film that is involved, and NO2 is what is present. NO2 is present. What if they ask us to eat the filtrate? If you are eating the filtrate, you're going to have a brown film is formed, which turns blue, turns paper red, and turns starch iodide paper what? Or start iodide paper brown. NO2 gas from NO3. Okay, so there are some people that are saying, okay, it's possible that oxygen might come up here too. No problem. But I'm just looking at if we have NaNO3 if we have it inside the solution, and NaNO3 is decomposing, all right, under heat. Okay, NaNO3 is solid. When you put it on flame, you can decompose to give you your oxygen gas. So I don't know about that anyway. Okay, let's look at this one so that we can quickly finish this class. Portion of the residue. Now let's go to the residue. Remember, in our residue, we have PbCO3. So we are expecting Pb, we are expecting CO3, 2 minus, we are expecting CO2 gas. So if you have this, to add this, you will see a white powdery precipitate, which is Pb2 plus. Okay, we would have had Al, aluminium, but aluminium is gelatinous. Okay, we would have had calcium. Calcium is powdery, but it's insoluble. So lead is powdery and soluble in SS. So let's take note. Zinc too would have had zinc. Zinc is soluble, but zinc is not powdery. Zinc is also gelatinous. That's why I didn't add it in this particular reaction. Now, let's look at portion of another residue plus ammonia. So we have powdery, white powdery precipitate form, but this time around is going to be insoluble. It's going to be so we have your Pb that is present. Okay. Now there are ways we can make sure that is Pb that we have in this particular reaction. Let's look at it. Another portion of the residue. If I ask to add dilute HCl, okay, when you add dilute HCl, you see an effervescent gas. Of course, you are going to write a colorless gas, an odorless gas, turn blue to red, and turns lime water making. Remember, if you are a student, all these things must be written for you to score CO2 gas from CO3. And if you are a tutor, make sure you teach your student that any effervescent that is coming from the reaction of dilute HCl here must contain all this observation for you to score the inference. Okay. Now, if you now divide the resulting mixture into certain portion that we have, this portion, if you dissolve it, if you add the portion that we had, that portion, and we try to warm it, okay, warming this portion, and we are seeing something like white crystalline precipitate which dissolve when warm and what, and reappear on cooling. It's dissolving when what, when warm. That's our precipitate, and it reappear on cooling. It is what, it is lead. Okay, you are working with Pb2 plus. Now, if you take that portion of the residue and add K2Cl2O7, then you want to confirm the presence of what, of lead. A yellow precipitate is going to be formed. Okay, now we are rounding up now. Thank you for staying tuned to the end of this video. Now, the portion of the residue now plus phenolphthalein. If you do that, you're going to have what, a pink coloration is formed, and CO2 minus will be confirmed. Thank you very much for staying to the end of this video. Thank you for watching. Make sure you subscribe, make sure you share the video, and God bless you. I know you have an excellent result on Thursday. See you. Bye.